Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. It's 9 a.m. Your manager sends you a 20-page security vendor white paper. There's a stakeholder meeting at 10, and they want 3 things. What matters? What's the risk? And what should we do next? You could start reading from page 1 and hope you find everything important. Or you could use Claude to accelerate the research, without blindly trusting the summary it gives you. Because speed isn't enough. If Claude changes a CVSS score, invents an affected version, or turns a recommendation into a requirement, your 5-minute summary could create a very real problem. So today, I'm going to show you a safer workflow. Prepare, prompt, verify, apply. You'll use Claude to move faster while keeping every critical conclusion grounded in the source. By the end of this video, you'll walk away with 3 concrete skills. 1. Build a repeatable 4-step summarization workflow that you can apply to any document. 2. Write precise prompts tailored for a CISO versus an engineer. 3. Verify AI outputs so you never act on a hallucinated CVSS score. These are the same techniques IT pros use to stay ahead of the fire hose. Imagine you're reviewing a 50-page firewall RFP. Buried deep in the document is a throughput limitation that could affect your design. A generic "summarize this document" might not give that detail the attention it deserves. That's why good summarization starts by understanding what kind of document you're reading. For a research paper, you may care about the objective, methodology, key findings, limitations, and conclusions. For an IT document such as an RFP, security advisory, or architecture report, you may care more about purpose, critical facts, technical requirements, risks, limitations, and required actions. Claude doesn't automatically know which information matters most to your decision. You have to tell it. Quick checkpoint. Should you summarize every document using the same checklist? No. What matters depends on the type of document and the decision you're trying to make. For a research paper, you may focus on the objective, methodology, findings, limitations, and conclusions. For an IT document, you may care more about critical facts, technical requirements, risks, limitations, and required actions. The lesson is simple. Don't start by asking, "What should every summary contain?" Start by asking, "What information matters for this document and this decision?" IT professionals don't have an information shortage. We have an attention problem. Think about everything you may need to process: CVE advisories, vendor security bulletins, architecture documents, RFPs, audit reports, security policies, incident reports, Microsoft documentation, cloud release notes, and internal technical documentation. The challenge isn't getting access to information. It's finding the information that matters before you need to make a decision. That's where summarization becomes more than a convenience. Used correctly, it becomes a research workflow. Everything we're about to cover fits into a simple 4-step workflow. 1. Prepare your document and your thinking. 2. Prompt Claude with precision. 3. Verify the output against the source. 4. Apply the summary to a real decision. This is the backbone of the video. Internalize it. Step 1 is prepare. Before asking Claude anything, understand what you're giving it. Is this a research paper, a vendor white paper, a security advisory, an RFP, an audit report, or an internal document? Next, consider sensitivity. Does the document contain confidential information, customer data, credentials, internal architecture, proprietary information, or anything your organization restricts from external AI services? If it does, stop and follow your organization's approved AI and data handling policy before uploading it anywhere. Then consider the document itself. If it's text-based, the content may be directly available for analysis. If it's primarily scanned pages or images, OCR or multimodal document processing may be necessary. Preparation isn't just uploading a file. It's understanding the source, its sensitivity, and what kind of evidence you need from it. Before you ask AI to summarize a document, spend a few minutes orienting yourself. But don't use the same pre-read strategy for everything. For a research paper, start with the abstract, introduction, and conclusion. For a technical report, read the executive summary, major findings, and recommendations. For a security advisory, look for affected products, severity, exploitation status, and remediation guidance. For an RFP, identify mandatory requirements, evaluation criteria, technical constraints, and exceptions. You don't need to understand every detail yet. The goal is to build enough context to recognize when an AI-generated summary doesn't make sense. A small amount of human context makes AI verification much easier. Quick checkpoint. Should you always skim the same 3 sections before using Claude? No. Your pre-read depends on the document type. For a research paper, abstract, introduction, and conclusion. For a technical report, executive summary, major findings, and recommendations. For a security advisory, affected products, severity, or exploitation information, and remediation guidance. For an RFP, mandatory requirements, technical constraints, evaluation criteria, and exceptions. You don't need to memorize one universal checklist. You need to identify the sections most likely to affect your decision. That's the purpose of the pre-read. Now let's move to step 2, prompt. And here's a template you can actually reuse. Analyze the attached document for audience. Use an only information supported by the document, produce output format in no more than length. Focus on Topic 1, Topic 2, Topic 3. For every critical number, date, version, CVE identifier, requirement, or recommendation, identify the supporting page or section when possible. If requested information is not provided by the source, write "not stated in source." Clearly separate confirmed facts from interpretation. Do not invent missing information. That's a much stronger prompt than "summarize this PDF." We're telling Claude who the reader is, what matters, how to structure the answer, how much detail we want, and most importantly, what to do when the source doesn't contain the answer. When you prompt Claude, you'll typically get an abstractive summary. It rephrases content to make it readable, but that can introduce errors. Extractive summarization pulls the exact original text. Look at this example. On the left, an extractive verbatim sentence from a CVE report. On the right, an abstractive version that rewords it. The abstractive version might change a number inadvertently. Always verify numbers before acting. Let's apply that template to a security advisory. Instead of asking, "summarize this vulnerability," we'll ask Claude to produce a structured security summary. We want CVE identifier, affected products and versions, CVSS score, if explicitly stated, known exploitation status, if stated, required or recommended remediation, and the source page or section supporting each critical finding. Now here's the important part. Suppose the advisory doesn't provide a CVSS score. Claude should not estimate one. It should return CVSS score, not stated in source. That's a feature, not a failure. A good research assistant doesn't fill every blank. It tells you which blanks still exist. AI summarization creates a data governance question before it creates a productivity opportunity. Before uploading organizational information, ask, is this AI service approved by my organization? What types of data am I allowed to send? How is submitted data retained? Under the terms that apply to my account, can submitted content be used for model improvement or training? Who can access the conversation or uploaded documents? And what contractual and technical protections apply? Don't assume the answer based on the product name, subscription tier, or something you read months ago. Policies and service terms can change. Verify the current terms and your organization's requirements. Then minimize what you send. If Claude only needs 3 sanitized sections of a report, don't automatically upload the entire confidential document. The principle is simple. Use the minimum necessary data in an approved environment. Now let's make data governance practical. Not every document carries the same level of risk. A public vendor white paper or published security advisory may be appropriate for an approved AI research workflow. But an internal document could contain information such as employee or customer data, credentials or secrets, internal IP addresses and host names, network architecture, security findings, contract details, financial information, or proprietary business data. Before uploading a document, ask, does Claude actually need all of this information to complete the task? If the answer is no, reduce the data first. Remove unnecessary sections. Replace real names or identifiers when they aren't relevant. Exclude credentials, secrets, and sensitive technical details. And if the document isn't approved for the AI environment you're using, don't upload it. The goal isn't simply, can Claude summarize this? The better question is, what is the minimum information Claude needs to perform this task safely? That principle is called data minimization, and it's one of the most useful habits you can build when using AI at work. Before uploading a work document to an AI system, run through this checklist. First, is the AI service approved for this type of organizational data? Second, does the document contain secrets, credentials, personal information, confidential business data, or restricted technical information? Third, can you remove information the model doesn't need? Maybe the analysis doesn't require real employee names, internal host names, customer identifiers, account numbers, or proprietary project names. Replace or remove unnecessary identifiers where appropriate. Fourth, understand the service's current data handling, retention, access, and training terms. And finally, if the document is too sensitive for the approved AI environment, don't upload it. Use an internal workflow or perform the analysis through an approved alternative. A tight deadline doesn't override your organization's security policy. Now we reach the most important part of the workflow: verify. Not every sentence deserves the same verification effort. Focus first on facts that could change a decision. For a security document, that might include CVE identifiers, CVSS scores, affected products, affected version ranges, exploitation status, patch versions, dates, and remediation requirements. For an RFP, pricing, performance limits, mandatory requirements, exceptions, and contractual deadlines. For every high-impact claim, compare Claude's answer with the original source. Low-risk descriptive language can be sampled. Critical facts should be verified. The more important the decision, the stronger the verification should be. Here's how we improve the workflow even further. Don't ask Claude for critical facts without asking where they came from. Suppose the summary says, CVE XXXX has a CVSS score of 9.8. Your next question shouldn't be, does that sound reasonable? It should be, where does the source say that? Require Claude to identify the page, section, table, or other source location when possible. Then verify it. If the document never provides the score, the correct output is not stated in source. This gives us a much better pattern. Claim, source location, verification. The goal isn't to eliminate hallucinations by trusting the prompt. The goal is to make important claims easier for a human to verify. Here's one of my favorite ways to structure an AI-assisted research summary, an evidence table. Create 4 columns: finding, source, status, action. For example, finding, affected version is 5.4 and earlier. Source, section 3.2, status, confirmed in source. Action, check your asset inventory. Now, another finding, CVSS score. Source, not stated. Status, requires external verification if the score is needed. Action, do not invent one. This structure forces the summary to distinguish between what the document actually says and what still needs investigation. It also makes the output easier for another person to review. Instead of receiving a wall of AI-generated prose, they can see what we know, where it came from, what we don't know, and what happens next. Now you're not simply creating a shorter document. You're creating a traceable decision support artifact. Step 4 is apply. But application doesn't mean blindly turning an AI summary into a production change. Suppose Claude extracts IP addresses, domains, and file hashes from a threat report. Treat those as candidate indicators. First, verify them against the original report. Then use your organization's approved threat intelligence and incident response processes to determine what they mean in your environment. Maybe you search your SIEM for those indicators. Maybe you check endpoint telemetry. Maybe you add them to an investigation. Maybe established policy supports blocking a verified indicator. The important point is, Claude doesn't decide your firewall policy. The summary gives you evidence that can support the next investigation or decision. Before acting, ask, what does the source actually support? What requires additional validation? And what action does our existing security process authorize? The same document can produce completely different useful summaries depending on the audience. A CISO usually needs business impact, risk, urgency, affected services, decision points, and recommended organizational actions. A senior engineer usually needs affected products and versions, technical prerequisites, configuration details, detection guidance, indicators, mitigations, patch or remediation information, and source references. The executive needs enough technical context to make a decision. The engineer needs enough evidence and detail to investigate or implement safely. Same source, different information density, different language, different purpose. One final checkpoint before we build our audience-specific prompts. Claude summarizes a threat report and extracts IP addresses, domains, file hashes, affected versions, and recommended actions. What's the one step you must never skip before acting on that summary? Verification. Go back to the original source. Confirm the critical indicators and technical facts. Then use your organization's approved threat intelligence, incident response, or change management process to determine the appropriate action. Remember the order. Claude extracts and organizes. You verify. Your approved process determines the action. Never turn. Claude set it into production change approved. Let's make this practical. Here's a CISO version. Summarize the attached document for a CISO. Focus on business impact, organizational risk, urgency, affected business services, and decisions leadership may need to make. Avoid unnecessary implementation detail. For each critical claim, identify the supporting page or section when possible. If information is not provided by the document, state, not stated in source. Separate confirmed fact from interpretation. Do not invent missing information. Now here's the engineer version. Summarize the attached document for a senior security engineer. Extract affected products and versions, CVE identifiers, CVSS scores if explicitly stated, prerequisites, indicators, detection guidance, configuration details, and remediation steps. For each critical technical fact, identify the supporting page or section when possible. If a requested value is absent, state, not stated in source. Do not infer missing versions, scores, indicators, or remediation details. Same document. Two completely different prompts. That's what audience-aware summarization looks like. Here's a reusable structure I recommend for serious IT research. Start with executive summary. 3 to 5 sentences explaining what the document is and why it matters. Then, critical findings. Each finding should include its source page or section when possible. Next, technical details, versions, CVE identifiers, configurations, dates, requirements, or other facts relevant to the document. Then create a section called Unknown or Not Stated. This is where Claude explicitly lists important information the source doesn't provide. Then, recommended actions. Only actions supported by the document or clearly labeled as analyst recommendations. And finally, verification required. List anything that needs external validation before someone makes a high-impact decision. So the complete structure is executive summary, critical findings, technical details, unknown or not stated, recommended actions, verification required. This structure makes AI output much easier to review, verify, audit, and act on. More importantly, it prevents a polished AI summary from hiding uncertainty. You can immediately see what the source confirms, what the source doesn't tell you, what action is being recommended, and what still needs verification before you make a decision. Let's put the entire workflow together. Step 1. Prepare. Understand the document type, sensitivity, and the decision you're trying to support. Step 2. Prompt. Define the audience, task, format, evidence requirements, and what Claude should do when information is missing. Step 3. Verify. Trace critical claims back to the source. Pay special attention to numbers, versions, CVEs, dates, requirements, and recommendations. Step 4. Apply. Use the verified summary to support a decision through your organization's normal technical, security, or business process. Prepare. prompt, verify, apply. That's the workflow. Claude helps you move faster. Source-grounded verification keeps speed from becoming risk. Here's your assignment. Choose a public advisory, vendor white paper, research paper, or approved test document. Run it through the 4-step workflow: prepare, prompt, verify, apply. But don't stop at summarize this. Ask Claude for source locations. Require not stated in source when information is missing. Build an evidence table. Then create 2 versions of the summary, one for an executive, one for an engineer. Compare how the information changes based on the audience. That's how you turn AI summarization from a convenience into a professional research skill. And in the next Claude Masterclass lesson, we'll go deeper into PDF analysis and learn how dedicated tools and AI can work together to inspect documents safely. If this lesson helped you, subscribe to Hired in IT for more practical AI and IT training. I'll see you in the next one.